creating 3 different types of molds using the same model. In today's video, we're going to examine different types of molds and what it takes to create each type of mold, and also the reasoning behind it, why we would create a block mold versus a cavity pour mold. Sometimes we have models that are actually ideal to creating either one of these molds, and we want to help you to determine which type of mold and material makes the most sense for your specific mold. So let's just jump into this project and see how we've done. Making a block mold using the MoldStar 30. Now, the easiest way to make a mold is creating a block mold. You simply put an enclosure around your model. As you can see here, we're going to use this Celtic skull. The MoldStar 30 is dispensed 1 part A to 1 part B by volume, and is then thoroughly mixed by scraping the sides and scraping the bottom of your mixing container. I chose this material because it has a low viscosity. It pours easily, it traps air minimally, and the air that is trapped in the mixing process will degas naturally on its own in the material's long cure time, which is 6 hours. And then we're simply going to pour the material into the mold box at the lowest point and let it fill up the entire mold box until it covers the model. One great benefit to making a block mold is the fact that there are many pour-on materials available for the mold making process. You can choose between different viscosities, sure hardnesses, working times, and cure times. Now, the material is allowed a cure of 6 hours before demolding. Once the material is cured, we can go ahead and demold. You can see that we're only spend 26 minutes so far on this build, on this mold setup, and that's because it is one of the fastest way to make a mold, but it consumes a lot of material. You can see that the mold itself is quite thick in areas, and a lot of that material is actually not used for anything. It's just filling a void, filling a space. Now we demold our model, and here you have our model and the mold itself created. As you can see, the molding rubber has captured all the detail from the original model. All right, so let's take a look at our block mold here. The working time for this mold was 34 minutes. That means we took 34 minutes to construct the mold box around the model, mix and pour the material into the mold box. The mold was then allowed 6 hours based on the material cure profile to cure so that we can demold it. So 6 hours and 34 minutes is the total timing that it took us to create this mold off of our model. Now, the material cost is $125 based on a gallon unit and the amount of the material that we used up out of that gallon unit. Now, why would a mold like this be good, and when would you use something like this? When you're creating tabletop size pieces such as these here, block molds are great because they're easy to handle size-wise, and you're not wasting a lot of time creating the mold itself. They are fast production molds. There's a vast material variety that you can select from, and the minimal time investment to create the mold boxes and pour the material is really the convenience that counts here. Now, there is a high material cost associated with these molds because of the amount of material they use up. They're a bit heavier and harder to handle. Basically, they're more difficult to demold depending on how many cuts you have in your mold. And there is usually some post-finishing efforts associated with block molds because there's usually a little bit more flashing on them. So let's take a look at the brush-on mold. Another way to make a mold is making a brush-on mold, and we're going to use the Rebound 25, which is also platinum silicone, has a mix ratio of 1:1 by volume. But unlike the pour-on mold, we're going to actually be brushing layers of material onto our model. This first layer we're applying in what's called a stipple technique, where we stippling the material in a very thin application to capture the detail. You can already see that this is a more time-consuming application method. However, it does save a lot of material. The first layer is now allowed a partial cure before applying additional layers. Also keep in mind that each layer will require a partial cure before adding more material to our mold. Beyond this layer, we're going to have to reapply another 5 layers to build up the necessary thickness that is required for a brush-on mold. So as you can see, multiple layers are going to take us much longer than a simple mix and pour over the model. Now, if you would like to see how a full brush-on mold is made with a support shell, you can simply click on the link, and that's going to take you to a full brush-on video using the Rebound 25. And before we start applying any of the support shell material, of course, we got to trim back the flange around our model and peel some of that silicone off. So you can see there is some waste. And then we're going to build up a separation wall that we're going to build up our support shell over. This is Sculptix soft oil-based clay, very easy to work with and manipulate. You can see I build up a wall of the Sculptix, onto which one we're going to put some sonite wax. Make sure that the plasti paste doesn't stick to any of these. And then we're going to mix our plasti paste too. The plasti paste too has a very convenient by-volume mix ratio of 1 part A to 2 parts B. Once we dispense the material, we can go ahead and mix it thoroughly, scraping the sides and scraping the bottom off our mixing container, and then get it out of the mixing container. It is exothermic and will heat up, so we get it out of the mixing container and then spread it around using a chip brush. Once the material is applied, I follow it up by using some isopropyl alcohol to soften the edges. The first side of our support shell is now allowed to cure for 90 minutes before proceeding on to the second half. Now we can simply remove the Sculptix oil-based clay from the first half of the support shell. Sonite wax is applied to the first half of the support shell to make sure that the two halves do not bond together. And then we're going to proceed to mix a second support shell side. And again, I'm doing this in 2 batches just because of my own preference. And you can simply apply the material, brush it around, and then smooth it out. Overall, you can see that this brush-on technique took much longer to make the mold than it was with the pour-on mold technique. After a 6-hour cure for the Rebound 25 and a 3-hour cure for the 2 sides of the Plasti Paste 2 support shell, we're finally ready to demold this project. And as you can tell, just the curing of these materials took way longer than the entire setup and making of the box mold that we created earlier. All right, let's take a look at our brush-on mold that we created here. Now, the total working time we spent on this mold was 3 hours. That's with the brush-on and making of the support shell. There was additional 12 hours that was spent on the in-between the layers and waiting for the material to cure. So total time invested in making this mold is 15 hours. The material cost for this mold is a lot less than the material cost for a block mold. It cost us $58 using 2 different materials to create this brush-on mold. A lot less material was used. Now, why is it good to make a brush-on mold, and when would you do it, and when wouldn't you do a brush-on mold for your application? Something that I consider is always the size of the models that I have. If I'm working on models that are larger than a foot and up, anything 5-6 feet, I always consider making a brush-on mold because it's going to use a lot less material. It's going to be a lot lighter for me to handle in the casting process. You have to think about those things ahead of time. Now, when wouldn't I make a brush-on mold? If you're working on a very small piece, you don't want to invest countless hours in making a tiny brush on mold. It's just a waste of time. Instead, you would just put a mold box around it and pour it. So keep those things in mind when making that consideration. There is a lot less material that we spend on making this brush on mold, which means the material cost savings versus a block mold are really great. Also, the lightweight of the mold, considered how much a block mold weighs, makes this type of mold much easier to handle. And also keep in mind some of the cons to a brush-on mold, the time-consuming aspect that it takes to make the mold, the multiple materials that we use for the mold itself. We do need to make a support shell, as well as the skill level that's required to make a brush-on mold versus a block mold. There are some chances for delamination of layers, so you really have to understand the chemistry of the material that you're working with and the working times. So let's go ahead now and jump into the cavity pour mold. We're going to make one more mold, and this is going to be a cavity pour mold. I'm going to use some aluminum foil to protect our model, because we are going to put clay over the entire piece. This clay is already rolled out to a specific thickness that I want my mold to be in. And then we're going to build up the clay some further to develop some keys. So you can see keys going down, a flange, and also a pour spout. First, we're going to create a support shell around the clay. To separate the two halves, I'm using some aluminum shims here. If you would like to see a full video on how to make cavity pour molds, you can simply click on the link and that will take you to that video. And again, we're going to use some sonite wax on all the surfaces where the support shell is going to be built up against. And for the support shell, I'm using epoxy putty called Freeform Air. Fantastic material to work with, 1:1 mix ratio by volume. We can simply mix the two components together until we get a uniform color, no streaking. And then we're going to build it up onto first one half and then the second half of the support shell of our model. Now, the material itself is easy to apply, easy to mix, and with a little bit of isopropyl alcohol, it smoothens out easily over the entire surface, creating a nice and smooth shell. The Freeform Air is allowed to cure for 24 hours before moving on to the next side. Now, once the first side has cured up, we can remove the shims and then put some sonite wax onto the first half of the support shell. More Freeform Air is dispensed, mixed, and then applied to the second side of our support shell. And just like on the first half, we're going to use some isopropyl alcohol to smoothen out the entire texture of the support shell so it doesn't leave any sharp edges. Now, the Freeform Air is allowed 24 hours to cure before demolding. And once that is all cured up, we can go ahead and demold the model by taking the two halves of the support shell apart and removing all the Sculptex clay that was built up on the inside of the shell. Now, to prep the shell for the next step, which is pouring off the mold, we're going to have to put some air vent holes. These vent holes will allow the air to escape out of the mold as we're pouring silicone into the mold cavity. To allow for a good airflow, I used a 1/4-inch drill bit, which is about 6 millimeters. Anything larger than that is unnecessary. It could potentially weaken the area where you're drilling the hole. And then we can simply remove that aluminum foil that we used to protect our model. And then we're going to secure the support shell around the original model. I'm using some hot melt glue for that. It should hold the support shell temporarily onto the working surface while we make the rest of the mold. Now, for this mold, I decided to use the Dragonskin 10NV because I know it has low viscosity. It's going to degas on its own very well.
Has a easy mix ratio 1:1 by volume. It's fast setting, and the rubber itself, dragon skin, is very elastic, and I'm going to be able to have this be a one-piece mold that just peels back and off the model. Now I'm going to pour the mixed silicone into our cavity here, and as the silicone leaks out of the air vents, we're going to plug those with some Sculptex oil-based clay. The Dragon Skin 10 NV is allowed to cure for 75 minutes before demolding. Once the silicone has cured, we can go ahead and demold our project by removing the support shell and simply peeling away the silicone mold. And here you have the end result.
All right, let's take a look at our cavity pour mold that we created. Now, this mold here took 52 hours to create. Out of that 52 hours, there was 2 hours that we actually worked on the mold. The rest of the time was spent waiting for the materials to cure. The freeform air that we made the support shell out of is a long curing material. Now, the material cost for this mold was $84. Even though we used 2 materials for the mold itself, it was still cheaper to make a cavity pour mold than it was to make the block mold as far as the material that we used. Now, why would you create a cavity pour mold over a brush-on mold or a block mold? Cavity pour molds lend themselves really well for glove molds or sock molds that are all one piece, and you can control the thickness of the molding rubber very precisely when you're creating the clay buildup over your model. Now, I wouldn't use a cavity pour mold over difficult models that have a lot of limbs sticking out, but more models that are unified in shape and lend themselves much easier for a unified mold that you can easily pull over the model. Now, small models just doesn't make sense to make cavity pour molds off because they're so tiny that a block mold would be just easier. Now, some of the pros for a cavity pour mold is the fact that it does use less material than a block mold would. Therefore, the cost savings versus a block mold is great. It's much lighter than a block mold would be because the amount of molding material that we're using is something really important to consider when working on medium SARs or even larger molds. As well as there's no seam line in the mold itself, which lends itself to making glove molds or sock molds out of. Now, one really nice thing about cavity pour molds is once you have the support shell and your rubber mold burns out for casting hundreds and hundreds and hundreds of castings into it, it will eventually burn out. You can take the support shell off that mold, put it around your model, and now pour a new glove mold off of that model, which makes it really convenient for production style molds. Now, some of the downturns to this type of mold is the fact that it does take a lot of time. It's time consuming to make this type of mold. It does require a higher skill level because you have to think about the support shell first before making the actual mold inside, as well as it does take multiple materials to create the mold. Besides the molding materials, we ended up having also to use the Sculptex oil-based clay to make the spacing in between the support shell and the model before pouring.
Now, if you got inspired and need some materials for your own projects, you can visit any one of our distributors around the world.
So, and there you have it. We showed you 3 different mold designs that we created to make a mold off the same object that captured the same amount of detail in every mold. Now, we hope that this video helps you determine what type of mold you should create for your particular mold and project design. We saw that a block mold, while it's very fast, can consume a lot of material, especially if we don't block out these dead ends in the mold boxes, while a brush-on mold and a cavity pour mold will consume a lot less material and result in a greater cost savings, but they do consume a lot more time to create. So you can see that one type of mold design is better for certain type of projects, smaller scale, while the other types are much better suited for medium and large scale projects. So if you like this video, make sure that you hit the thumbs up button, and to keep up with our latest mold making, casting, and other videos, remember to subscribe. Now, if you have an idea about what we should do next, please let us know down in the comments below.